Thank you for joining us today. Hey, we've got a number of folks still signing in, so we want to give them a chance to get settled. So we will be starting at about 3 minutes past the hour. Hey, good morning and afternoon. It's a pleasure to welcome you to our broadcast titled Scaling with Redis Enterprise. Our presenter today is Jake Ungerman, a solutions architect at Redis Labs. Over the next 30 minutes, you will learn how to scale your Redis databases dynamically without any downtime across multiple nodes and multiple cores. Jake will discuss the topology of a Redis Labs enterprise deployment, and he will show how easy it is to increase memory limits and numbers of shards to achieve a truly scalable performance system. Today's broadcast is being recorded. Following today's event, an email with a link to the recording will be sent to you for sharing with your fellow workmates. Jake will be taking questions throughout the broadcast. There is a question and answer feature in the control panel that you can use to post questions. Questions will be answered in the order that they are received. Thank you again for joining us today, and at this time I'll turn the broadcast over to Jake. Jake, take it away.
Thanks, Sharon. Hi, everybody. I'm Jake Ungerman. I'm a solutions architect at Redis Labs. A solution architect is an engineer who helps customers understand the software, understand how to build scalable, highly available, and performant systems. So without further ado, let's move into the agenda. So today we're going to be talking about scalability in Redis Enterprise. So high availability is a separate topic, and we'll tackle that in a subsequent webinar. But today's focus will be on scalability. So if you have any questions on scalability, this is the place to ask. Okay, next slide. So let's talk a little bit about Redis and Redis Labs. So Redis is, an open source in-memory database. It was created in 2009. It's highly performant, very simple, very easy to understand, and it's geared on performance. Redis Labs is the sponsor of the open source project. So the creator of Redis actually works for Redis Labs. He heads our open source division, and he runs that division. We also have a commercial division that creates the enterprise product. So the enterprise version of Redis is geared towards scalability and high availability. So you can run that as a service in a cloud. You can run it on bare metal, a virtual machine. It doesn't really matter. So we have a deployment model where we host everything. We have a deployment model where you can download the software and manage everything yourself. Or we have somewhat of a blend of the two where you can provision your infrastructure and our DevOps engineers can access it remotely and do all the management for you. So we have a lot of flexible solutions there on exactly how you want to manage the enterprise version of the software. Okay, so let's move on to the next slide, and we'll talk a little bit about how scalability works in open source Redis. So in open source Redis, you have what's called a cluster. So a cluster is basically a bunch of what are called cluster nodes. So a cluster node in the open source Redis, it's an instance of Redis that holds a subset of the data set, such that all the nodes together in aggregate hold the entire data set. And that allows you to distribute operations to different cluster nodes to achieve parallelism and scalability. So in this model, there are a lot of processes to manage. There are a lot of connections, there are a lot of configuration files to manage. It can get a little tricky and involved as you start to scale out. And there's another issue in that in this model, the client is basically responsible for the shard key calculation, like how to route the command to the right shard. So whatever client you're using, whether it's .NET or Java or PHP or Python or whatever, that client is responsible for figuring out which node to talk to. Also, there are times where the application needs to be cognizant of how the sharding mechanism works. So it gets a little involved as you start to scale out and things change. So there can be times when the topology changes here and the client may not know that the topology's changed, and it may issue a command to a specific cluster node, and that cluster node may respond with, hey, that shard key doesn't exist here. You need to go talk to this other node, this other cluster node. So there can be some redirection there that could potentially increase latency for that particular request until the client is able to build up its view of how the cluster is laid out. So that's how it works in the open source world. Let's move on to the next slide. We'll talk a little bit about how it works in the enterprise version. So in the enterprise version, you don't have this concept of a cluster node. You have a node. So a node in the enterprise version of Redis is an operating system. So that operating system could be a virtual machine. It could be in any one of the major leading brand cloud providers. It could be bare metal. It doesn't really matter, but it's basically an operating system. So a cluster consists of multiple nodes, multiple operating systems, and you usually have an odd number of nodes in your cluster, and that's for network partitioning. So in the case of a network split or a partition, you want to have an odd number so that you have a majority of the cluster who can survive and basically continue on going by nominating a master node. So if you have 3 nodes, a majority of 3 is 2, so in the event of a network partition, it's highly likely you'd have 1 node on one side of the partition, 2 on the other. 2 is a majority of 3, therefore you'd be able to continue having a master node. So you have these 3 nodes. It could be 3, 5, 7, 9, etc., but you have an odd number of nodes. And upon each one of those nodes, you can see there layered in that diagram, at the bottom level you have instances of Redis or shards. So an instance of Redis, or a shard in this case, holds a subset of the data, just like it did in the previous slide. And on top of that you have this layer of management. That blue layer there is the enterprise software that is part of each node in the cluster. So there can be multiple shards on a given node. You can fully utilize the CPU capacity of a given node. Like open source Redis is singly threaded. It's very performant, very simple, but as you want to scale up on a given node with multiple CPUs, it becomes a little challenging editing all those configuration files and managing all that in the open source. In the enterprise version, we allow you to easily scale up on a given node and fully utilize all the cores on that machine. Now, for those of you who are trying to follow along here, you'll notice I didn't put anything about the client interactions on this slide. I'm going to save that for a subsequent slide. But first I want to talk about exactly how you would scale this up and out. So let's go to the next slide. So to talk about this, I've simplified this diagram a little bit. So the previous diagram I had 3 nodes in my cluster, and here I'm only talking about like 1 or 2. I did that just to keep things simple. If I start to put 3 nodes everywhere, then fonts get smaller and the icons get smaller and it gets very confusing. So just bear with me while I simplify this just down to, I'm talking about 2 nodes here. So the title of the slide is Scale Out, but I can show you both scaling out and scaling up. So I'm walking you through a progression here from left to right of different states of my cluster. So let's say I start off over on the left, and I've got a single node, and upon it I have a single shard, basically a single shard of Redis. So let's say I reach some kind of limitation, whether it's CPU, could be RAM. In this case, it wouldn't be RAM, but maybe it could be network. It's some bottleneck of some kind, and I need to scale up. So the way I would do that in the enterprise version, and I'll actually demonstrate this in a minute, is I would do what's called resharding, where I'm going from one shard to multiple shards. So that first transition there, I'm going from a single shard, and I'm basically splitting the data into 4 pieces. And my data set into 4 pieces, and now I have 4 instances of Redis that are running on a given node. And the enterprise software makes that very simple to do. So now let's say I reach, maybe it's a network performance limit, and I want to rebalance the number of nodes, or rebalance the nodes that I have in my cluster. So I would have a second node, maybe that's a second node I would spin up, or maybe it's a node that's already in my cluster. And I could do that next step, which is rebalancing. That's basically taking the same number of shards and rebalancing them onto multiple nodes. So now I have the ability to offload some of that processing to another node. And then the last step over there on the right, I can continue this process where I keep splitting these shards further and further, such that I can go from having 4 to 8 to 16 to et cetera, et cetera. So this is an example of how you can go from a single instance of Redis, a single shard, into multiple shards spanning multiple nodes in the enterprise product. So if we can go to the next slide. So I didn't talk about the client interactions previously, but let me do that now. So in the open source Redis, you have over on the right, you have all these cluster nodes that are communicating with each other regarding the topology and where things, heartbeats and all that kind of stuff. And then you have your client application over on the left here. Now in the open source, you have multiple connections to all of the cluster nodes, and they're not always persistent. So you'll find that a lot of the latency in Redis is actually at the network layer from tearing up, bringing up and tearing down network connections. So you have two problems. One, your application or your client has to keep track of where the shard keys are, and the other is there's high overhead in the connection setup and tear down. So let's go to the next slide, and we'll contrast that with the way it works in Redis Enterprise. So in Redis Enterprise, again, we have over on the right there that 3-node cluster, and there's that layer of management software colored in blue there, and one of the components of that management layer is a proxy. So that proxy is part of the enterprise product, and that proxy stands between the application and the cluster, and it does a few things. So the first thing that it does is it gives your application basically a very simple endpoint to communicate with. So as the topology changes, if there might be a high availability event or a scaling out event, etc., all those topology changes are hidden from the application. They don't have to know that any of those events are occurred. There's no hiccup. There's no data loss. Everything just kind of happens behind the scenes, and the application just is none the wiser. The other thing that it does is that it can create a smaller number of persistent connections to the Redis instances. So that gives you the ability to avoid the spin up and tearing down of sockets going to each connection. You're basically keeping a smaller number of persistent connections to that back end, which can improve latency. And the last thing that it does is the shard key calculation to send the right request to the right shard is actually done within the proxy and the enterprise product. So if you choose to, you can avoid having to do that in the application. So I have one more slide on this topic. If we go to the next slide, there's another benefit of that proxy in that it also does multiplexing and pipelining. So it's intelligent enough to know if I have, say operations 1, 2, 3, 4 that need to go to shard A, it can basically package this up in bulk, so to speak, and ship those off into one operation and avoid, minimize the latency is the goal here. So I'd like to go to the next slide and talk about one other aspect of the enterprise product in terms of scalability. So we have the ability to do WAN replication in Redis Enterprise. So if I had 2 data centers that were separated by a wide area network, in the enterprise product, it's extremely simple to spin up a new cluster and say, okay, this cluster, make it basically a carbon copy of the source cluster. So all the operations that are invoked on that source cluster get replicated over the WAN. They get compressed, and there's some deduplication logic to make things faster. And so it's asynchronously replicated over to that destination cluster. So that makes it very easy if you have the need to replicate over a WAN. And then if we can go to the next slide, I just wanted to illustrate the point that you can actually have a many-to-one relationship. So here I can actually have 2 source clusters that are replicating over to a destination cluster, and that destination cluster doesn't necessarily have to have the exact same topology as the source. So just food for thought, that capability is in the enterprise product. Okay, so before I go to a quick demo, I wanted to go to the next slide and just talk a little bit about an example use case. So one of our customers is ATPCO. ATPCO works in the airline industry. They do fare calculations or fare publishing in the airline industry. You'll find that Redis is used very heavily in the travel industry. They were open source users, and they had been open source users for a couple of years, and Redis was used extensively, but they chose Redis Enterprise PAC. PAC is the name of the enterprise product that's deployed on site, like on premise, basically, in their own data center. So they chose Redis PAC because it made clustering very simple and very effortless. And there's a quote there from one of their chief architects saying, you know, it's very easy to do with a click of a button, very powerful and easy to use. So let me actually show you how easy it is. So I will now give a demo. And let me get my screen sharing working here. Okay. Okay, so I have, I'm showing you my screen. So I have an instance, I have a Redis cluster deployed in AWS. It's a 3-node cluster. It could, like I said, it could be deployed in any of the leading brand cloud providers, but I have this one in AWS. So this is the administrative interface for Redis Enterprise. Right now I don't have any databases defined, but I'll go ahead and click a new one. You'll notice that we also support the Memcache protocol as well, but I'm going to focus on Redis. So this software is super easy to install. It takes about 5 minutes per node, so in about 15 minutes you can get set up. So I'm going to go ahead and create a database here. Give it a name called demo. I'll call it 10 gigabytes, or give it 10 gigabytes. This is telling me how many resources I have allocated within the entire cluster, so it's giving some feedback of what's available. There are tons of advanced options here that I could drill down to, but I'm just going to skip all that and just going to show you how easy it is to create a database. So I've created a database, and so this is the endpoint that my application would use. There's a fully qualified domain name and a port, and that's, as an application user, that's all I need to configure. Everything that happens in terms of scaling out or high availability or what have you is all insulated from me. I just use that endpoint, and that's all I ever need to use. And if I go over here and look at some of the metrics, the enterprise product gives you, tons of metrics here. So right now I don't have any data going into this database because I just created it. So let me fix that. So I'm going to start up a client here. This client is called Memtier Benchmark. Memtier Benchmark is an open source project. You can check it out from GitHub, and it's used for stressing Redis instances. So I just fired up my benchmark program, and you can see here I'm doing about 1 million operations per second, give or take, and it's hovering around 0.75 milliseconds. So sub-millisecond latency, about 1 million operations per second. So that's with a single shard. That's with one Redis instance being managed by Redis Enterprise. So let's see if we can make that better with some scaling. So I will go over here to my configuration. Now I'm not going to walk you through this entire cockpit of knobs here, but I just want to focus on one thing. I'm going to show you some scalability. So right now I do not have clustering enabled. So I'm going to go ahead and check that clustering checkbox, and it's going to ask me how many shards do you want. So right now I have 1, so it's offering me 2, and I can click plus or minus to give myself more or less as I see fit. But I'll go ahead and click 2 and click update. So what's happening right now is the cluster manager in the enterprise product is spinning up a new shard. It's initiating a data duplication process such that the existing shard duplicates its data to the new shard, and then at the end it cuts in half the amount of data, so that the original shard now has half the data, the new shard has half the data. So I'm now running 2 shards in parallel, and you can see my throughput is still there, just doing fine, but my latency has been cut down. So before it was 0.75 milliseconds, and now it's hovering around half a millisecond. So before I was basically waiting on a single shard or a single thread or a single process of Redis to get my work done. Now I'm actually talking to 2 shards. That proxy is proxying the client request to 2 shards for decreased latency. So again, you'll notice that there was no downtime, no dropped connections, no hiccups. The application had no idea that the topology changed behind the scenes. That proxy hid everything behind it to initiate that change. So that was a super fast demo of how to increase the number of shards in a Redis deployment. So I will turn it back over to Sharon, and maybe she can ask a few questions that may have been offered during the webinar.
Hey, thank you, Jake. And perfect. Yeah, we do have a handful of questions here. The first one, what's the preferred client for .NET, and is there any support for it?
So there are multiple clients for many of the popular languages like Java and .NET. Those clients are not created by Redis Labs. They're in the open source community, so the open source community maintains them, but we provide support for all of those clients to our enterprise customers. So you should use the client that is most suitable for your needs, and just rest assured we will support it.
Perfect, thank you. Here comes another one. How much downtime with an application would a user expect to incur when scaling with open source Redis?
So the downtime that you would incur there, it really depends on how deft you can maneuver all of the clustering topology changes. I've never done an experiment with the downtime, but I can say that there could be some latency as well, because when the topology changes, your client does not know that the topology changed, so it will issue a command to a cluster node, and the cluster node will respond back saying, I don't own that data anymore. You need to go to this other place. You need to ask somebody else. So your application could be impacted. Yeah.
Mm-hmm. Okay. We've got quite a few streaming in here. You were showing a graph on one of your slides, and this person wants to know, the proxy service has a limited and persistent connection. Can the app/client have a limited and persistent connection to the proxy?
It can. That's up to the app. That's up to the client. So it depends on how the client is implemented. But it's totally possible to do that, and you would probably want to do that in many cases to achieve good performance in terms of latency.
Okay. Here's another one for you. What's the recommendation on size of a single key?
Well, there's a hard limit of 512 megabytes, which is for a key size that's pretty big. The general rule of thumb is you want to try to minimize it as much as you can, but not to the point of it being inscrutable. So, like if you have something that's like user colon some integer colon something else, that's probably okay. If you have something, if there's, what you want to avoid doing is having like an incredibly long English description, like multiple words separated with underscores, like something that's really long, because it does take up space in RAM. So basically do it within reason, but try to avoid excessively long key names, but don't be afraid to use something that's human readable or human understandable, as long as it's not like ridiculously long.
Perfect. Here's one more. How helpful is Redis Enterprise for IoT solutions?
So, I was talking to a prospect about a week and a half ago, where their business use case was they ingest a bunch of IoT data, but they only process it at the end of the day. So it's kind of batched up. And what happened was the solution that they were using, which was not the enterprise version of the product, had a high availability event, and they basically lost a day's worth of production data. So I know high availability will be covered in a different webinar, but for those kinds of use cases, whether the data is streaming in and you can't afford any downtime, or even if it's being batched up, you still can't afford any data loss. The enterprise version makes the high availability and scalability very easy, and in terms of the ingestion, a lot of times those IoT clients they're difficult to change, and so you want to insulate any topology changes as much as possible from those clients. So Enterprise lends itself very well for that.
Perfect. And we have one last question here. How do you compare Redis to Mongo regarding scalability?
So I would say, yeah?
Yeah, I would think that this would be, comparing Redis open source to Mongo and then Redis Enterprise to Mongo.
Right. So there's a couple of things there. One, in terms of Redis, we're all about performance. So we're all about getting your data very fast. That's a different, I just showed you a demo of 1 million operations per second in sub-millisecond latency. So we're all about the performance. There are different use cases where you may want to ingest a bunch of data and then query it infrequently, or when you do, you don't really care how long the query takes. That's different than I have an operational situation where I have to have that data like right now, sub-millisecond latency. So there are different use cases for, different solutions are geared for different use cases. I would say that the sharding is a lot more involved in, let me say it the other way, the sharding is much simpler with Redis Labs Enterprise because that proxy takes care of that for you, so your application doesn't have to worry about the sharding implications, which is when you start to get to the volumes that we're talking about for IoT data, there's really no way that you can, with a traditional indexing solution, to avoid having your client get very involved in exactly how the data is sharded. That line gets crossed pretty quickly.
Well, great. Well, hey, Jake, thank you very much. That brings us to the end of our broadcast and to the half-hour mark here. And thank all of you for joining us today. An email will be sent later this afternoon with a link to the recording of today's broadcast. So go out and make it a great day, and bye for now.